Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this lesson is a function called the Malloc function, and it's for memory allocation. Now, what I'm going to use this function for is to dynamically allocate memory for a piece of code that we want. So for example, I'm going to use the struct that we used previously, the employee struct, so that we kind of keep it all tied in together. And what I'm going to use the Malloc function here is to solve a problem that I've mentioned a number of times with regard to the struct. And it's the fact that we have to leave enough storage space here, as you can see, for the last name, for somebody's last name, or indeed for their first name. And I'll just go back to their first name if we were deciding how long that should be. We have to leave enough memory to be able to deal with anything from my name, which is just Sean, or you might have a small name like Jim, or you might have a name that perhaps covers more than one word, particularly if the person has a double-barreled or a triple-barreled name. And so it may well go to beyond 20 characters. 20 characters may not be enough in order to store that person's name. And yet we can clearly see that if we were dealing with somebody like a Sean or a Jim, we're wasting memory there because we only need 3 or 4 bytes for that. So what is the solution to this? Well, we've already shown that we can use pointers. But the problem with the pointers as we use them so far was that when we created a temporary variable, such as just making a string copy and putting something like Sean into that, or Fergal as we have in some of the examples down below. I think we have an example of that still there. Or we did this, we said Fergal pointer first name, and we put it equal to Fergal and things like that. So we can point it at that. But the problem is this is a temporary variable. The C program makes that as temporary storage. And as soon as we go out of the scope that's in, so out of the function that's in, that will be removed, and therefore the pointer will no longer be pointing at the proper data. So it worked as a kind of a stopgap for us for a time, so that you understood that we could use pointers in the structs. But it doesn't really work as regards setting up a database system or something like that to actually store some of these employees' information. So what we want is a system whereby we can ask the operating system for just enough memory for what we need and no more. And if it can supply us with that memory, then we can copy information into that, and that'll be stored there for good. So rather than having an array here that's 20 characters for every first name and 20 characters for every second name, instead, if we have a Sean or a Jim or something like that, we'll only take up 3 or 4 bytes. If we have Aloysius or some big long name like that, then we will have enough storage for that, and in the long run we will save a lot more memory. So that's what we're going to do. So the first thing I'm going to do is I'm going to change the first name and last name in my struct there to just a pointer to a character, so that we point in the right direction. Unfortunately, this system here of filling the thing up with information doesn't really work for my purposes. So I'm going to get rid of that information, or just comment it out for the moment. We'll leave it there in the program in case I need to refer back to it. So what I'm going to do here is I'm going to make my employee called Sean, and I'm going to do this for both the Fergal pointer one down below, but also for just an ordinary struct which we've called Sean. I'm going to put that as a lowercase there. So I've made that one called Sean, and what I'm going to do is I'm going to fill this up with information. So I'm going to say Sean dot, and you can see here, if you've this version of Dev-C, it's quite helpful in offering you some of these possibilities, but you can also just type it in. So I'm Sean dot first name, and what I want to do is that's a pointer, remember, so I want that to point to some memory that I'll ask the operating system to allocate to me. So to do that, I use the function called malloc. Now malloc will return to you the pointer, but it doesn't know what type of pointer you want, so it just returns a pointer to no particular type, of what's known as a void pointer. So we need to tell it what type of pointer we want that to be looking at, and so we do a thing called a cast. Sorry, that's how it's spelled, but we want it to point to a character. Okay, so a character pointer. So we do that and we put it in brackets in front of it, and what that tells the compiler is that the pointer that comes back, we want that from now on to be interpreted as a pointer to a character so that it knows how to act. It's known as a cast, a little bit like putting molten metal into a cast would make you cast iron. Okay, so it would mold it into the shape. So in the same way as that, that's where the word comes from. Now, in order that we are allocated the right amount of memory, we need to tell it how many bytes. We can't just tell it how many integers or characters or otherwise we want. We need to tell it how many bytes exactly. And obviously, because different types of variables can have different numbers of bytes depending on which system they're on, we need to be a little bit more general about how we write it. So what I'm going to do is I want, and this is not really the way we would do this in the long run, but it gives us a stepping stone to where we want to go. So what I would say is I want to put the name Sean in here. And so to do that, what I'm going to say is I'm going to say string length. And I'm going to make the temporary variable Sean. That'll be destroyed soon after it's used. So string length of Sean. And the other thing that I want to do is I want to multiply the length of Sean by the size of a character. Now, as it so happens, in this particular case, this is not really necessary because a character is 1 byte. But in cases where it might be an integer, you'd be multiplying that by the size of an integer, which would be 4 bytes, and therefore it is important to include it. Okay, so that's the malloc function. It allocates memory, and we look for the we put in the temporary kind of string there, Sean. It'll count the number of characters in that and multiply that by the number of characters, and that will return us a pointer to the memory that has been allocated for that, which should only be 4 or 5 bytes in this case. It'll probably include hopefully the null terminating character as well. Okay, so that's that bit done, and the thing is that it hasn't actually put the name Sean into first name yet. All it's done is it's given us enough space to hold Sean and no larger. So what I can then do is I can then use my strcpy and I can say I want to copy into Sean dot first name. I want to copy the string literal Sean. Okay, and therefore again it'll make a temporary variable of this, or a temporary string called Sean, just enough time for it to copy it into first name, which is pointed in the right place, and that'll be the job done. So I'm going to do the same for the last name. So I'm just going to copy that, put it here. Last name. And then I'll put in the other information for Sean here very briefly. So we'll go for age there. We don't have to put in any particular order. So again, we're going to put in 20 for that. We'll put in Sean dot, what else is to go in there? His gender. We're going to put in the M. Now these are all very standard sizes, so it'll be the same for every person. Sean dot hourly salary, and again this will be the same size as any other, so there's no point dynamically allocating the memory for this. 8.65 is what we're putting in there. What I'm going to do at this point is I'm going to run this program. Unfortunately, the Fergal one is going to probably fail on us because of the fact that it's expecting a character array there rather than a pointer. So just going to move that to, actually it's fine where it is. I shouldn't have this stuff here though. That should be up the top. Okay, because we do all our declarations first. So this will probably fail when it gets to the part about Fergal. Oh no, it's just actually printed it out, is it? Or is it coming up with a problem? It seems to be working for the moment anyway. But we can see there that the employee name is Sean Mullery, 20 years old, gender, and he earns €8.65 per hour. Okay. Now, for the Fergal one, where we have the Fergal pointer, and again, it's working for Fergal at the moment, but it's temporary storage of that, so we want to do that in a better way. So we'll use the use this, and again, what we want to do is we want to put in the Malloc function to allocate the memory for this so that we keep it. So again, we do the cast first, char for pointer, and we put in the strlen, the string length of Fergal, and multiply that by size of the character. Okay, and then we do a Fergal, I'm going to do a string copy here, str cpy, and copy into that the string literal Fergal. So we'll do the same then for the last name. And we copy in the name Henry there. You can see I've spelt it wrong here, but it still would have worked because it's the right size. And we put in that information, and then that will all be printed out as well by the employee struct. Okay, so we can see all that information coming out correctly. Now there's one last thing that we have to do. Because the operating system was asked for that memory, and it wasn't a lot of memory, it was only a few bytes, but because it was asked for it, it's important that we actually give it back. Now, Microsoft Windows is probably very good at making sure that it takes it back of us, even if we've forgotten to give it back. But other operating systems and so on that you may end up working with as an electronic engineer are not likely to be as judicious about taking that memory back. They leave it up to us to hand it back. So to do that, what we have to do is we must use the free function, and we must tell it what pointer we're referring to. So that means for the Fergal PTR here, we have to tell it the first name. So free that one up. Then we want to free up the last name, and we need to do the same for the Sean one as well. So free, and this is the last thing you do, or you do it when you're finished with the memory, you free it up. If you don't, it's known as a memory leak, and it can be problematic because it can mean that you're no longer able to use memory that the system actually has because it thinks it's in use already. One word of caution though on this, and it's that let's say sometime later you decide to remove the place where the memory allocation was done. Let's say you no longer want to do that memory allocation, but you forget to get rid of the free that is associated with it. The danger with that is that the compiler in most cases, or the operating system in most cases, will allow you to free up memory that's associated with that pointer, even though it was never allocated in the first place. So that's a very dangerous thing to do, because what can happen then is it can actually it can mean that pointer is no longer pointed at anything, but the operating system thinks that memory is now free to be used for something else. And the problem is that memory might be in use somewhere by somebody else, and by somebody else I mean by another program or another piece of software or something like that. And so you end up getting these very, very unusual intermittent errors, and they can be very, very difficult to find and track down. So what we will be doing later in 1 or 2 videos time is we'll be looking at a little bit more of an efficient way of doing what we're doing here. This is just to kind of prove the concept to you and show you how the different allocation systems work. But really the best way to do it is to have a function that deals with each of these, and so that we make sure that when we're finished with it, we free free all the sort of stuff up as well, and we'll be looking at that as we go through the next few lectures as well. In the next lecture I will show you how we would use this with the scanf, so that I'll leave that for the next lecture. I just want to show you that this is still working now that we've put in those free things there. Okay, and that's coming up fine there. One thing to notice there, by the way, I've spotted that there's a warning message coming up there, warning incompatible implicit declaration of built-in function malloc, and it's enabled by default. So what that's basically saying is it's a very unusual language that it uses, but the word implicit declaration means that we haven't said where we've declared malloc, whereas previously it was the same with printf. We explicitly said that printf was in stdio.h. It's in there, okay? The string functions like string copy are in string.h, but we didn't say where malloc was, and so it included it of its own accord, but it wants to warn me that I shouldn't really be doing that, and that I could be I might be trying to do something else. So sorry, it's in stdlib.h, and that'll get rid of that warning. And that's that warning gone. Okay, so I'll leave that that video at that.